Alright, so let's talk about one-way sensitivity analysis using the numerical analysis. So the method is the same as numerical analysis for treatment threshold we discussed in week 2. The key difference here between the sensitivity analysis and treatment threshold analysis is that the treatment threshold tries to find the values at which the treatment and no treatment have the same expected survival probability. On the other hand, the sensitivity analysis can consider as a more general than treatment threshold analysis and try to find out decision chain or not when we vary the value of the variable. In our case right here, the probability of PE within the range of the PPE. So the numerical analysis can be performed numerically by constructing a decision tree, as we discussed in the previous lecture, especially in week 1, where we utilize the proactive method to construct our decision tree. And then we gonna put or insert the uncertain variables as a variable in our analysis. In our case here, that the probability of the disease PE, so we call PPE. So here's the variable. We try to vary the values, and then based on all the other parameters right here, we're gonna try to calculate the expected value of AC and the expected value of no AC methods or option. And then we're gonna compare which option gonna be recommended based on the range or the new value of the PPE. So in order to do that, we can either plot or tabulate the expected value for all the values for each of the options. And in this case, Microsoft Excel or Google Spreadsheet can be used to construct our table. And here's an example. We're gonna come back to this example in a moment. But from here, we can see that by utilizing the decision tree, we should be able to identify which variable consider in our one-way sensitivity analysis. So by looking at the tree right here, you can see that the value of PP right here is uncertain. The value of fatal P and ham right here also uncertain right here. The value of fatal PE right here also uncertain, and the value of fatal ham right here also uncertain. So technically, by looking at this one, we can see 4 of them: 1, 2, 3, 4. We should notice that when the value of P could be identified or given the values, we should be able to calculate the probability of no PE, right? Because this the two events are complement. So this one equal PPE. So this one going to be 1 minus PPE because the summation of the two probability equals 1. The same here. Fatal PE in ham and survive. In this scenario right here, two of them are complement and the summation equal to 1. Okay. So in our example right here, we're gonna consider the variable in our one-way sensitivity and analysis gonna be PPE. Right, so consider one-way sensitivity analysis using numerical analysis for the variable PPE. So in this one-way analysis, we assume that the value of PPE plausible range from 0.1 to 0.5. And we're gonna change the values or vary the value of PPE from 0.1 to 0.5. And here we're gonna assume that the changing step equals 0.04. So the next two values gonna be different by 0.04. We can make a smaller change, but the analysis gonna be not different. Okay. So in order to do the one-way analysis, we're gonna compare the expected values outcome of different options. So here we have two options, AC and no AC. And to determine if our decision will change when we vary the value of the variable in this range. So as we knowing that the original value is gonna be a 0.19, now we're gonna think, or now we're gonna ask the question: what if the value of the PPE right here not equal 0.19, maybe smaller or maybe larger? So the values we're gonna consider for the value of the PPE right here gonna be 0.1 to 0.5. So it's implied that about 10% of the population have the PE, and about 50% have the PPE. So it's a pretty wide range compared with the actually of any disease we have, right? So with this assumption, then we're gonna calculate the expected survival probability of two different options: AC, anticoagulation, and no AC, mean no anticoagulation, corresponding to each of the values of PPE. So we can see that we can vary the value of the PPE from 0.1 to 0.5, and then we can calculate the corresponding with the value of PPE right here for the AC and for no AC. And based on these two expected values, the survival probability, we can decide which the optimal decision right here. Greater gonna be the better. So here for the first case right here, we have the AC have expected value 0.9918 and no AC 0.975. So obviously optimal decision could be the AC option. All right, so maybe gonna go a little bit more detail. How do we calculate the expected values? I think the calculation of expected value gonna be come back into the decision tree we constructed before. So let's consider a very first scenario or very first row of the PPE. So in this case, we have the PPE equals 0.1. So we plug the value of the PPE right here. So we can calculate the value of the no PE gonna be 0.9 because the summation equal to 1. Similarly, we have the PPE 0.1 and no PE 0.9 right here. The rest of the parameter right here gonna be the same because we consider only one way sensitivity analysis. So we're gonna change only one variables. All right, so how do we calculate the expected value of AC and no AC right here? The calculation pretty straightforward, right? So the first step, we're gonna calculate are we folding the tree? For the first step right here, we calculate the expected value of the first channels right here. So that's gonna be 0.01 times with 0 plus with 0.99 times with 1. So we end up with the expected value of this node right here equals 0.99. Similarly, we have the expected value of this right here equals 0 times with 0.008 plus with 0.992 times with 1. So that end up with the expected value 0.992. So we have the two expected value right here. We have the probability of PE equals 0.1 and no PE 0.9. So expected value of this, refolding the tree one more time, equals 0.1 times with 0.99 plus with 0.9 times with 0.992. So this one gonna equal 0.9918. So that's gonna be the expected value of the AC option right here for the values of PP equals 0.1, and the rest of the parameter right here gonna be the same. Similarly, we can calculate the expected survival probability of no AC option. Here we have this one the same. So the value of expected value of this node right here for one time folding gonna equal 0.75. That equal 0 times 20.25 plus with 1 times 0.75. So this expected value equals 0.75. Now we're going to calculate one more time to obtain the expected value of no AC option. That's equals 0.1 times with 0.75 plus with 0.9 times with 1 right here. So the expected value of the no AC equals 0.975. That's gonna be here, right? That's a lot of calculation, but if we use the Google spreadsheet, we can calculate pretty quick using the formula we just discussed. So I'm gonna show you step in a minute. But in this slide right here, we just discussed the step in order to calculate the expected value of AC option and no AC option given the new value of the PPE. Okay, and based on that, we're gonna determine what the optimal decision. So in this case right here, AC is gonna be optimal because the expected value of survival probability greater than the no AC scheme. Alright, so if we do the same procedure for the other values of PPE within the range, we're gonna end up with the whole table as we show over here. We also can plot the values of the AC right here, that's representing by the blue line, and also the no AC option right here, representing by the red line right here. So we can see that within the range from 0.1 to 0.5, the value of no AC option right here always smaller than the value of the AC option. In other words, we can reach to our conclusion is that our optimal decision is the same over the range of the PPE from 0.5 to 0.1 to 0.5, and that's the AC option. And with that observation, we can interpret that we are very confident with our decision of the AC recommendation when we calculate at the beginning the PPE equals 0.19. So 0.19 can be somewhere over here, and analyze this range of sensitivity right here. We consider from 0.1 to 50 right here. The calculation right here pretty the same. Once we have this value right here, all of the formula applied to AC and no AC gonna be the same. The Google spreadsheet right here, I have provided in the lecture, so please go over there and download it, or you can just using the Google spreadsheet in order to do the calculation. So this is free. Google spreadsheet is free software, so we can using that for our analysis, right? So the next video I'm gonna show you the step in Google spreadsheet. How can we put the number of values right here, and how can we utilize some of the built-in function of Google spreadsheet in order to facilitate our calculation right here. Okay.